let's take a look at our problem of the day today. It says a triangle has an area of 35 square feet, big triangle. If its height measures 7 feet, how long is the base that works with its height? Okay, so in other words, we're taking the same height that's coming together with a base. A triangle has an area of 35 square feet. Its height measures 7 feet. How long is the base that's going to work with that height? All right, so let's take a look at the problem here. Actually, we've got two different figures that this could apply to. And actually, there's a third option. Actually, there's probably many different looks that you could have for this figure. But we have given you a right triangle. We've given you an acute triangle. And over here, we could draw in, and I'll do that in a little bit, we could draw in an obtuse triangle. I'm afraid we might run off the page if we were trying to do that. But you get the idea. You get the idea. And we're going to take a look at that one and see what happens. I'll draw that in along with the way. First of all, formula for a triangle. Doesn't matter whether it's right triangle, acute triangle, or an obtuse triangle. All right? So let's see. First of all, if I have a right triangle, there we go. We're going to pick up 7, and we'll call it base. We don't know what it is, but we do know the space in the shaded area there is 35. All right? Now, in this problem, the base is pretty easy to spot, but you say, well, Ernie, where's the height? It's an acute triangle. So what we got to do, we got to create that height. All right? And the height is still the same height as our other little guy over here. He's 7, but the 7 is right here on the inside. All right? And we're going to figure out, by the way, this is making a right angle there. So that's the deal. So in looking at those, you see, this one was created for you. This one, you've got the height coming to connect with the base. All right? Now, I said something about an obtuse. Let's look at that in a minute, all right? But let's go ahead and work through this little puppy. It's pretty straightforward because the formula, no matter what, is going to be 1/2 base height. Base times height. Folks, I've given you, what's on the inside? We have 35, right? And they are square feet. Square feet. So what we're going to do here, so we'll just put it right in there so nobody gets too excited. There we go. So what we're going to do, we're going to put that 35 in the place of A because that is our area. We're going to keep 1/2 rocking and rolling right there. We do not know the base. We'll put a B there. But we do know the height is 7. All right? So it's all multiplication there. It's all multiplication. Now, a couple of things we could do. We could go ahead and say 1/2 of 7, get 3.5, and divide 3.5 into 35. With a calculator, that works pretty easily. All right? But some of us may not have a calculator, and we're going to work it easily without having a calculator, not having to go to that nasty old decimal. What we're going to do is we're going to clean out that 1/2. We're going to clean out the 1/2 on both sides, and to do that, we're going to have to multiply through by 2 to clean up the 1/2. So it's like multiplying 2 over 1 here, bring some 1s down there. So what this does for me, it sends me over here to be 70, and all of a sudden these 2's have disappeared, my friends. So what we've got is 7 times B, or sometimes we like to write that, 7B. Well, it looks pretty easy to do at this point, doesn't it? We're going to divide 7 into 70, and our B value equals to 10. That's the base. Now, quick thought about it. If you multiply 10 times 7, you got it, 35. 10 times 7. 35, after you half it, right? Got to remember to half. Yeah, 7 times 10 is 70. Divided by 2, you get 35. And once again, yes, they look like different figures there, but they have the same amount of area and the same base and the same height. All right? So that's what we want you to notice here off the problem of the day. I did promise an obtuse real quickly here. Let me show you. If we were to take, looks like these are pretty close to the same amount. Let's go run it here. We'll create. We could pick this. Let's see if we can get this to work. There's a base of 5. And I'm going to see how tall is this thing. So it's somewhere about right here. We'll put it right there. And we'll bring this down. It's an obtuse triangle when I connect everything together. And there we go. And we're going to still say that base is unknown. All right, that's our base B. Obviously, this angle is bigger than 90 degrees. Say, well, Ernie, where do you put the altitude? Well, you've got to measure back a little bit here. We're going to take it back this way, and we're going to drop that altitude straight down make a perpendicular, make a right angle, and there you go. That's where the 7 is, and yes, the base still goes from here to here. And by the way, this area also, this little area out here, 35 square feet also. So there you have it, really quick in a nutshell, a look at it. But remember, you can have 3 different types of triangles, and where that altitude lands, it all depends on what kind of angles you're dealing with in the triangle. So pretty cool stuff there. But the formula, 1/2 base height, still holds true.